Hello everybody, I'm Thora Tenbrink, Professor of Linguistics at Bangor University in Wales, and I'm going to present my ideas on how to achieve joint spatial reference with a smart environment beyond physical robots. So, one of the main drivers of my research is the idea that we want to find out what people are thinking. It would be very easy if we could just look through a keyhole and see what other people are thinking in their minds, in their brains. But actually what we need to do is to look at how they speak in order to find out what they're thinking. So we use language as a representation of thought, and specifically we use, if we want to understand how people think about space, we look at spatial language and how it represents spatial thinking. Now, a lot of research has been done on these things, and if you've got two people talking to each other, they will agree on a number of things. For example, if they're looking at an object from the same point of view, they will agree on a perspective because they're sharing it. Or if they're sitting opposite to each other, they have to agree on a perspective. Things like that. There's a lot of research on all that. However, if you're actually talking to an automatic system, a number of problems arise, particularly if you don't have a physical robot to talk to who or which does also have a perspective that you can share. So a ubiquitous smart environment system, which is sort of everywhere but doesn't have a particular viewpoint, might be a very difficult interaction partner to talk to, and that's something that I would like to explore today. So the outline for my talk, I will very briefly talk about spatial reference in general, how it's ubiquitous, and then I will look into some of my previous work in concerning challenges when trying to establish spatial reference. So one first challenge is about agreeing about orientation in dialogue. The second is about identifying a perspective in sailing. The third one is about finding a reference frame when oriented in a different way. And the fourth one is agreeing on a reference frame between languages. All that seems a bit all over the place, but you will see how it all comes together when I come back to the idea of smart environments. So bear with me, I will at the end come up with a solution for all these problems, and I'm looking forward to having some discussion on that. So spatial language and cognition, as I said, it's been researched quite a bit. We know that space is very fundamental. It's a basic human conceptual domain. People think about space or talk about space quite a lot of the time, and how we understand space will affect our life and thinking, and it will also reflect our life and thinking. So it all comes together in terms of if we didn't have spatial language, we wouldn't be able to look into the thought, and space is actually really central to human life. There's quite a few things that we know about human spatial cognition. For example, that we think about spatial relationships in schematic terms, and so we don't necessarily use specific metric information like centimeters and so on if we don't need that. So we basically say something is to the right, which is a category, sort of qualitative category, and we don't necessarily specify the angle. Also, there's a lot of research and findings on the functional nature of spatial terms. So, for example, if you are if something is if an umbrella is over you, it will protect you from the rain. If the rain comes from the side a bit, the umbrella will not be specifically directly above you, but it might be at a diagonal angle, and just so that the umbrella can fulfill the function that it's needed for. The other thing about spatial language is that it's ubiquitous. So everyday language contains quite a lot of information about spatial positions, relative locations. We talk about where things are, where objects are, and so on. And we also use spatial language in more abstract domains. There's a lot of transferred usage, so where we say things like Christmas is around the corner, and stuff like that, where spatial language seems to help us to understand more abstract domains, which is not something that I'm going into today, but it's just sort of to show that how ubiquitous and how important it is to understand spatial language and spatial thinking. So a few challenges, as I've promised. The first one is agreeing about orientation in dialogue. So this is a case study of spatial inference processes, something that I've worked at with Gesa Schole and Elena Andonova in Kenny Coventry quite a while ago. And we did a study that was motivated by the idea of moving house. So when we move house, we will talk about where things go. This one goes into the living room, on the wall to your left as you walk in, or put the chairs around the dining room table. So we explain where things are in a sort of schematic way, and people know roughly where how things are oriented, located in different rooms. So it sort of all makes sense for the speakers involved. So people don't necessarily say how objects would be oriented. So if you think about that, if you've got a table and 4 chairs and you bring that into the dining room, you wouldn't ask, and how should I turn these chairs? You would sort of automatically place them around the table so that all chairs will face the table. So that's sort of a natural thing to do. And so here again, functions are very important, and we know about them because we've got that sort of world knowledge. So let's just have a quick look at spatial reference, which might have will come into play in that sort of scenario. There are very many different kinds of spatial reference. For example, you can use on and in and at as topological terms, or path-related terms along and so on. There's much evidence for effects of functional relationships, as I've already mentioned. So here's a picture for that, where you can decide for yourself whether you think that the man sits under the umbrella or not, depending on what that umbrella is for. Definitely not for A in this case. And then we've got the class of projective terms, like in front of, to the right, and so on, and those require a perspective. And we know of many misunderstandings and ambiguities that come about because people do not necessarily mention the perspective that they are using when they use the word terms left and right. It's sort of notorious, and we have a lot of everyday experience on these things. So in previous years, I've spent a lot of time thinking about the schematic concepts underlying reference frames, and I've come up with a sort of intuitive diagrammatic model, which I just wanted to briefly explain to give some background on reference frames. So this is the idea for the reference frames as such is based on Levinson, 2003, who suggested that they are left and right are understood in terms of intrinsic or relative reference frames, where intrinsic reference frames are based sort of on a 2-point system, where you have got a relatum, so something that an object is related to. That relatum needs to have intrinsic features like a front side, and then you've got the locatum, which is the object that is located, and you locate that relative to that relatum with its intrinsic sides. So if you say the table is in front of me, then in front of me is determined by my intrinsic sides. Because I've got a front side, I can say something is in front of me, and we don't need any external perspective for that. Likewise, you can say there's a tree in front of the car using the car's intrinsic features, and again, you don't necessarily use an external perspective for that. However, you can look at a car from the outside as well without relying on its intrinsic front, and use a relative reference frame, which is represented here by the triangle. So you might be positioned on the triangle, you use your own perspective, and then you can say the locatum is to the right of the relatum in this case, or if you turn things around a bit, you can say something is in front of the car, not using the car's intrinsic features. So you can't necessarily look at the language in order to determine which of these two reference frames are used, and that's something that gets us into trouble sometimes, because you don't necessarily know, is it a 2-point system or a 3-point system that's currently being used. Another complication, which has sort of snuck into my slide right here, is that sometimes things are moving. So I've brought in the movement direction, where you can see that, for example, if the relatum moves, you can move to a different position from the position of the relatum to the position of the locatum, and that will again affect the language being used. Or you can say you move something from the position of the relatum to the position of the locatum. All of that comes with a lot of interesting reference frames effects, which I won't go into detail here. I will come back to the idea of movement in a moment when I talk about sailing, but I won't explain more of that here because it can be quite complicated. But if you're interested, by all means, have a look at that article, Reference Frames of Space and Time in Language. So in the context of coming back to the moving house scenario and the fact that we don't necessarily always need to know how objects are oriented, but sometimes we do say that. So something points to the right or how it should be oriented. It's an under-researched field, actually. There's a lot of research on where things are located, but not necessarily where they are, how they are oriented. So we collected a corpus where we looked at some expressions. And here are some examples. The sofa's back is along the left wall, for example, something that somebody could say, or the chair is oriented towards the table. Both of these examples establish orientation information by reference to a relatum, very similar to saying the chair is to the left of the table, where the table is the relatum. So we've got a very similar notion here of relatum. Or we can use something like the chair points to the right, where we've got this left and right problem. Somebody's perspective must be being used, and we don't know which one it is. Or we could use compass terms and say something like the chair's back points north. So that's not projective terms, it's a different system, which Levinson introduced under the umbrella of absolute reference frames. In this case compass-based, which are sort of unambiguous and can always be used. So in the context of looking at orientation, two relevant questions that I wanted to ask here, so there's more to that study than that, but I will just restrict the explanation to this. So one question is, how explicit are we in dialogue, and what does this depend on? And the second question is, how much information do we need? Under what circumstances does communication fail? So that's one of my favorite topics anyway. So how does communication work? When does it fail? What can we do to improve it? Where do ambiguities come from? What are misunderstandings all about, and that sort of thing, which is particularly interesting when we talk to automatic systems, because then we can really see how communication normally works, and automatic systems make these normal principles fail very often. So the corpus we collected was built on a scenario where, which is sort of indicated schematically here. I won't go very much into that, but basically you've got two empty dollhouses. One is pre-furnished, the other one is empty. So we've got one person who is the director or the speaker in that scenario, who has got a pre-furnished house and explains to the matcher or the addressee how the house should be furnished. And all the furniture is sort of at the side of the empty house, and the matcher sort of needs to listen to the instructions of the director and try and put all the furniture into the right places. So that's basically the scenario, and it's sort of very natural. Not that we would furnish doll houses very, very often, but from the moving house scenario, it's something that we are used to, and we sort of can deal with the furniture situation in houses. So there's nothing unnatural about that. So just focusing on the orientation issue, so we coded in our corpus whether people gave sufficient orientation information, so that sort of complete information that makes it unambiguous. So complete information needed to contain explicit reference to one of the locatum's axes, and the directedness, if applicable, and the fully specified direction. If one of these required parameters was missing, for example, the underlying perspective or projective term, we coded the orientation information as incomplete. Also, the orientation of diagonally placed object was considered as completely described when diagonality was made explicit. So this is how it looks like. It's basically a corpus with lots of utterances, and whenever there is orientation description, we coded whether or not it was complete. Here's an example for complete orientation information. So I hope you can see that there's a little picture of a colorful cupboard. And this corpus was collected in German, so jetzt haben wir noch diesen bunten Schrank, and now we have this colorful cupboard. And speaker B, the addressee, is actually alert, doesn't know about the orientation, wants to know how it's oriented, and actually asks, and where does the colorful side point? And the director dutifully explains it points into the bedroom, and that clarifies it. The orientation information is given unambiguously, and speaker B, the addressee, can place the item. So that basically explains what we need. The object's directed axis is determined by the colourful side that the matcher actually suggested, and the director then introduced the relator, namely the living room, the bedroom. Here's an example for incomplete orientation information. So the utterance is simply put the shower on the middle wall, and we don't have any information on how it should be oriented. There is a clarification question by the matcher, but the explanation given by speaker A is simply not sufficient. There's still ambiguity in there. Not wanting to dwell too long on that, but here's the result. This is how the participant placed the object, and it should have been placed like you can see on the right hand side. So there was clearly a misunderstanding there, and something went wrong. So that's basically what we did and what we looked at in the entire corpus. And now I'm going to give you a very surprising result. We had various different conditions with different scenarios how the furniture was put up, and I'm not going into that, but basically the green bits show you successful communication concerning orientation. So most of the time, as you can clearly see, no matter what the scenario was, it was successful, and that across all of the different coding categories, whether the orientation information was complete, incomplete, or entirely missing. So it was missing half of the time, basically, at least in one of the conditions. And the little red bits at the bottom, that's the percentage of failed orientation, where the orientation ended up wrong. And that's just mostly below 2%, so really, really low percentage. So most of the time people did orient the furniture in the correct way, and it had nothing to do with the scenario and very little to do with how much information was actually given. So my relevant questions were: how explicit are we in dialogue, and what does this depend on? So what we found concerning orientation information, the answer is speakers are only explicit when they feel they need to be. They often assume their interaction partner will know. So, and how much information do we need, and in what circumstances does communication fail? In this particular scenario, listeners were often able to infer the intended meaning. They were drawing on background knowledge and shared situational input, common ground. Communication did fail in a number of cases when the common ground was not sufficient to interpret the given input. So speakers draw at least as much from the common ground as they do from the actual utterance. And that, as you can probably already see, is very bad news for automatic systems. Common ground is something that is relatively difficult to achieve with an automatic system. So, do we always share common ground? So this is sort of leading over to my second challenge, which still hasn't got anything to do with automatic systems, just showing a different area in communication where things might become a little bit difficult. So identifying a perspective in sailing. So I showed you this schema before, and what I'm going to suggest is that moving forward, means I'm changing my own position. So if I move forward, I go from the position that I have now to a position in front of me. That's basically what forward movement means. So in front of me, the position in front of me in this case is the locatum, and the relatum is me with my view perspective, so in front of me, and then we add the movement direction. So I am moving into a position that is in front of me, in front of my previous position, and that means moving forward. So this is relatively straightforward when we are just moving forward in our own view direction without any further complications. So the movement direction is determined in relation to the relatum, so my own view direction. In this case, the speaker is the relatum in an intrinsic reference system. Okay, now a complicated scenario, not sailing yet. This is rowing, so this is my rowing boat, which I'm very proud of. Now my question is, am I rowing forwards or backwards? As you know, when you row, you look not in the direction you're actually going. You sort of sit the other way around in the rowing boat. In that sense, you row backwards. However, if you take the movement direction in itself, that of course will be moving forward. And then there is a different sense in which you can also row backwards. And this schematic diagram shows you how the complication comes about. So if I take my view direction as the basis for saying what forward is, I would be rowing backwards. If I take the movement direction as the perspective for the reference system, then I would be moving forwards. So that's in rowing. And of course, there are other scenarios where things might become even more complicated. So now I'm talking about sailing. So this is where I live, lots of yachts on the water, and I do dinghy sailing, lovely hobby. So if things were very easy, we could just say all the directions correspond to each other. So in this slightly complicated diagram, you see things like the coastline, CL, wind direction, sort of abstract wind direction coming from behind. The sailor sits in the boat in the way that they look exactly in the direction they are going, and the boat moves straight forward to a location, and then we might have the river direction, the tidal direction, and whatever else. So there's a lot going on here. Everything's in the same direction, and of course the boat is moving forwards. Now, if you've ever sailed, you know that this is completely hypothetical. This situation will not happen. It looks rather more like this. So the boat isn't actually oriented in the direction it is going. It's slightly slanted. The wind direction is not directly from behind. The sailor isn't looking in the direction they are going. The boat won't be aligned with the coastline or with the tide or with the river direction or whatever. So it's all over the place, and there are lots of directionalities. And now it's really difficult to say on which of these directions you should take as a basis for saying going forward. So what does it mean for a boat to be going forward, for a sailing boat under these conditions? So the reason why I looked into that is because I noticed that sailors actually don't really say forward. That's not what they do. They say course made good. That's the sort of sailing expression that they use for getting closer to the goal that they want to reach. So there must be some intuitive knowledge that forward could be based on many things, so underlying perspectives that are determined by the various directions that are going on. So spatial reference in sailing is a bit more complicated than in other movement scenarios. Okay, ready for the next challenge? Finding a reference frame when oriented in a different way. Now I've got a friend who does vertical dance. So people are sort of, they hang on the ceiling with a harness and do all sorts of funny things and turn around and reorient themselves. And it's a beautiful type of movement and of dance. It's really nice. But Kate told me that communication in this scenario is really, really challenging. So we did a little study where we asked people which way is up and which way is forward when oriented in a different way. So there's an expression, stand on the wall, which looks like this in the picture, where the normal orientation that you have when you stand upright is definitely distorted. You stand on the wall, and people answered the question of where is up in various different ways. So if you imagine this situation indoors, then they would be saying, okay, up is the ceiling, or up is towards the audience, perhaps, or it could be the wall. And then when asked which way is forward, you basically get the same set of answers, a little bit differently distributed, but a bit more people said it's actually the wall rather than the ceiling, but they still have got the same sort of range of options there. And which way is left, that's always stage left in that situation. So there was, which corresponds to the dancer's left in this case. A different situation when somebody is actually looking downwards, hung upside down. Again, we've got several different options, not so much correspondence between different options, but again, upwards could be ceiling or floor, depending on which reference system you use. And forward could be the wall or the audience. Again, left has been interpreted as stage left. And then I don't really have a picture for that, apologies. Stand sideways is when you sort of stand on the wall and then turn left. So you're actually not oriented towards the sky or the ceiling. And that's when things really completely go wrong. Up is sort of okay because it's either the ceiling or the sky, or maybe the audience, where the head is basically. But forward and left just came up with so many different options. So it really fails when people are not oriented in their normal canonical way, standing upright. So it's really a problem for Kate Lawrence and her vertical dance. Okay, next challenge, agreeing on a reference frame between languages. So this is drawing on 2 studies with a number of colleagues. So here you see some faces. So we wanted to look at reference frame interpretation in Spanish as opposed to English, because Javier Olocui Redondo studied in Bangor, he's Spanish, and sort of intuitively found that reference frames are interpreted differently in the 2 languages, which I thought was remarkable. But because these things are really subtle and you don't necessarily realize what's going on this sort of meta-linguistic awareness level. So we actually tested that. So the idea is sort of based on the fact that we know that speakers of different languages talk about space in a number of different ways. So there are some communities, some cultures that draw on compass directions almost wherever they are. So they would say things like, there's an ant on your southwest leg. So you see the picture in the middle, a funny little ant on a leg. And Anushka, my co-author, insists that she wouldn't say it's the southwest leg. She would say it's on your left leg. And I tend to agree with her. That's very likely what I would say as well, and probably what most of you would say as well. But there are communities and cultures that use compass systems for such scenarios. So speakers of different languages do that. In Spanish, it's more like English, in the sense that projective terms like left and right would be used for such scenarios. But as I said, there can be differences. One of the differences is that the repertory is different. So we've got these 2 options for interpreting where the ball is. The ball is to the right of the table, the ball is to the right of David. We've got these 2 different pictures, and you can sort of think for yourself whether, if you hear the ball is to the right of the table, whether you would choose the left hand or the right hand picture, and what you would do if you heard the ball is to the right of David, whether you would choose the left or the right hand picture. And you can sort of do the same thing when thinking about the 2 Spanish options. And I'm not going to try to speak Spanish now because it's not my gift. But what I can tell you is that there's a difference in the repertory. In English, we've got two constructions available, to the left of David and on David's left. So intuitively, a lot of English speakers tell me that on David's left would always be an intrinsic reference system, always the 2-point system. So David has an intrinsic left, and that's where the object will be if you use that construction. Whereas if you say to the left of David, it might be a different viewpoint, something an outsider another person might look at from a different perspective. In Spanish, we don't have this sort of intrinsic possessive construction. So we have one construction that corresponds to the left of David, but that's not possessive in the same way. And there's a marked construction which roughly translates to I see an object, I see a person and the object is on the person's left or right, or I see a statue and the ball is on the statue's left or right. So that is a marked construction, which means it's not sort of as frequent, not that common. So we were asking if this possible intrinsic only possessive version of on David's left doesn't exist as such in Spanish. What does that mean for the choice of reference systems? So the hypothesis we started out with was that Spanish speakers choose reference frames differently from English speakers, and that might be related to what kinds of objects we have. So we manipulated these factors, so whether or not the objects had sides, whether they were anthropomorphic, so they had a human form, whether they were animate or not, whether they were human or not. So we hypothesized that these features matter for reference frame choice. So this was the scenario. We showed pictures like this one to English and Spanish speakers. If they chose object A here, they would be using an intrinsic reference system, and with B, they would be using a relative reference system. We varied the animacy of the reference objects as well as the syntactic construction to the right of Samuel or to Samuel's right. In English, we found a very clear pattern. If the syntactic construction was to the right of Samuel, people chose their own point of view in the relative reference system, but if the syntactic construction was to Samuel's right, they chose an intrinsic reference system. There was a little bit of variety, which could be related to animacy, but really not a lot. In Spanish, we get a very different picture. People preferred the intrinsic reference frame under most circumstances, but they switched to a relative reference when the non-possessive construction was used and when the reference object was not animate and not shaped like a human. So this is our main result. Animacy matters in Spanish much more than it does in English. This might relate to a fundamental concept that affects language use across many languages: inalienable possession. You can't take the right side away from Samuel, it belongs to him. This kind of idea seems to matter in Spanish more than it does in English, and this is reflected also in other grammatical constructions in the language. But mainly what we get from here is that the linguistic repertory affects conceptualization, and so people are influenced in what they say by the language they speak. So obviously the question to ask is, what about Spanish-English bilinguals? What about those speakers who speak both languages? How will they react? So we did another study, and this is now the publication is submitted, so we are hoping to publish the results here, and I'm going to give you a glimpse of what we found there. The glimpse is like this. You get a pattern that at a glance, just from my side, really looks very, very similar to the Spanish pattern. All the results are sort of similar, no matter whether people speak Spanish or English, whether they are actually living in Spain or in an English-speaking country. So what we get basically is that the syntactic construction shows a pattern that is akin to monolingual Spanish data in both English and Spanish. And if we look at animacy a little bit more closely, this pattern is actually closer to the monolingual English data in both English and Spanish. And there are no effects of residence, so in contrast to previous research, we found that it doesn't matter where people live. So this is quite interesting as a result. So it's a combination of influences from both their languages in an intricate ways, which is something that shows us that the language we speak affects how we think about space in different ways. So thinking back to the 4 challenges that I showed you, for the first we can see that agreeing on a reference frame requires common ground because speakers are rarely fully explicit. The second one was agreeing on a reference frame is difficult when the situation and context provides complex and contradictory information, for example in sailing. Third, agreeing on a reference frame is difficult when the normal perceptions are distorted. So if you think of the scenario in vertical dance, you can remember that the normal references to left, right, up and down and forward don't quite work the same just because people are not oriented in the normal way. And agreeing on a reference frame is difficult when the speakers don't share the same cultural, conceptual and linguistic background. So if you imagine a Spanish and English speaker, a Spanish speaker and an English speaker talking about reference, special reference, they might come up with different results or different interpretations of the same utterance without actually noticing that, because for them it's just normal. Okay, coming back to smart environments, which is after all the topic of this talk, I will briefly talk about features and the challenges involved in that. Just sort of thinking about what is the scenario I have in mind for the smart environment. So it's not any old robot with a shape like a human or whatever. No matter where we are in the development of those, I'm thinking of an environment which is ubiquitous, that is sort of installed in a house. For example, in somebody's home, think of an elderly person who wants assistance with all sorts of things, who maybe can't see very well anymore and wishes to just have to say, switch the light on, open the window, help me do this and that. So some system that knows the user and their needs, that does not require a specific position, so should be sort of present in the entire house, has no physical presence and relies on sensors that are spread through the house and talks to the user. So that's the scenario, and you can imagine that that might be quite useful. So imagine a situation where this elderly person says or asks the system, where are my pills? And ideally the system should respond in a way that is useful for the user. So what could be useful? Well, pointing gestures are a bit difficult if you don't have arms, okay? So there is no physical presence, no way of pointing to anywhere, because the system is everywhere, but it's also rather invisible as such as a system. So pointing gestures are not applicable in this scenario. So how about doing what the system does best, like a spatial ID in some database? Well, I suppose the user won't really understand that, so that is ruled out as well. How about a visual representation on a display? Okay, that works in many scenarios, but in the scenario that I've just laid out, the user really wants to just talk to the system because maybe they're half blind or whatever. They can't really cope with an iPad or phone or whatever, let alone with a computer. So that's not what this user wants. It's not adequate. So for a visual representation, you do need user adequate displays and a situation adaptive database which is updated all the time and can sort of represent all sorts of different locations, for example, for the pills. Then, of course, in human interaction, what we might do is refer to past actions. So you could say something like, you took them at breakfast. So the user might infer, so maybe the pills are still where I left them. But that, of course, requires the system to know all this, to know not only that the user took the pills at breakfast, but also that this inference is possible, that the pills are still there, and this way of interacting. To me, it sort of seems more human than something that a system could easily do. How about route directions? How do you get there? So, go straight on, turn left, on the table on your right, you will find them, something like that. Well, route directions are notorious for being misunderstood. They are difficult to produce and difficult to remember. So ideally, the system would track the user's movements and sort of guide them step by step, so gradually updating the user's movements. It might work, but it requires a lot of tracking. So, okay, how about just describing the object's location? Okay, fair enough, let's look at that. So here we are back to spatial references. So that's what I sort of introduced at the beginning. There are different types. One thing to remember is that they are schematic, they're function-based. You know, remember the thing about sitting under the umbrella. It's not something that systems are particularly good at, to say the least. Thinking in non-metric qualitative terms, situation, adaptive and functional and all these things. So spatial reference has been a problem for computation for quite a while. A lot of that is captured by the work you are doing and, and machine learning approaches and all sorts of things, but it always comes with challenges. Topological terms, for instance, are extremely context dependent. They presuppose proximity notions and topological reasoning. So in order to say something is in something else, you need to have the concept of both the geometric and the functional notion of in. Then there are path-related terms that come with geometrical constraints, and that, for example, in order to be able to say along or across or something like that, you have to have a certain scenario where these terms work. And also a lot of inference processes are involved very often in order to, you know, if you say something like walk along the wall, you will have to infer that you don't sort of bump into the cupboard or anything like that. So there's a little bit of world knowledge, or quite a lot of world knowledge involved in that as well. Take distance related terms, it's near or it's far, they are relatively vague, and of course they come with expectations of different levels of granularity. So if a town is near or close to another town, that's a quite different concept of near than saying the spoon is near the plate or something like that. And then of course there are projective terms, and they have really been proposed as something that is much more context-free and function-free than all these other terms are. And there are models for that, and it's really a good solution for many scenarios, except for the fact, of course, that we have different perspectives and that we have all these challenges that I've been talking about. So, for example, agreeing on a reference frame requires common ground because speakers are rarely fully explicit. So that's what I demonstrated, and if you think of smart environments, there really isn't a lot of specific common ground, only what's been implemented. If you think of specific house environments, home environments, specific users, machine learning approaches might struggle a bit more than having something generic, some generic dialogue context. So everything needs to be implemented or machine learned. Might be possible in the future, but it's not something that can be easily, you know, all the common ground that is required is difficult to implement. Agreeing on a reference frame is difficult when the situational context provides complex and contradictory information. For example, if we think of a sailing scenario, okay, if we are thinking of a household, it's not complex in the same way, but if you take away all the common ground that we have about household context and about our own homes, then the more you think about that, the more problems actually pop up. A household context is actually rather challenging with all its details. Third, agreeing on a reference frame is difficult when the normal perceptions are distorted. So if you think of vertical dance, somebody upside down, standing on the wall and that sort of thing, well, an automatic assistance system that is ubiquitous and spread out throughout the house, it doesn't even have a body that can be oriented in some way, will have struggle, will have problems, you know, building up this common ground concerning orientation and building up reference systems that are dependent from specific viewpoints. So the perception of the system will be fundamentally different from that of a human, not only because the physical body is lacking, but also because there are multiple different viewpoints and different ways of dealing with that computationally. And then agreeing on a reference frame is difficult when the interactions don't share the same cultural, conceptual, or linguistic backgrounds. And in a sense, you could say that smart environments and humans speak different languages, and they really rely on different conceptual systems. Of course, the system will speak, the user's language, but they don't have the concepts necessarily implemented. So all these challenges are definitely relevant for this context. So I'm basically what I'm saying is maybe projective terms and reference frames are a good solution in that context, but it won't be easy and it will come with a lot of challenges. So I'm going to propose a solution here, which is open for debate, and I'm really curious to see what you think about it. So think back to the slide where I talked about orientation. How do we refer to object orientation? People relate to a relate term like the left wall or the table, and there are the projective terms. But then there is a pointer to absolute reference frames, compass-based, which are unambiguous. You don't need a lot of information. You don't need a lot of common ground to understand a specific direction. And as I've also told you, there are some cultures and communities that use compass-like directions, or the equivalent of compass directions in their languages, to refer to even small objects within a scenario, not just locations of towns or environmental places. So it can be done, humans can do it. It doesn't have to be the compass, and sometimes it's uphill, downhill, or whatever works in other cultures depending on the scenario. So it's something that is being done, and it's a lot less dependent on viewpoints and anything else, which is probably why it's so established in some cultures. Now, could that work? Well, I've got my doubts that people will get used to compass terms indoors, because that's just not what we do. So we haven't grown up with that sort of knowledge. We don't have the awareness in most cultures to be able to say where north is. You can give it a try. Do you know where north is right now? Different for everybody watching, I suppose, because we are in different locations. But anyway, we don't know necessarily where it is. Maybe if we look outside, we can orient ourselves. Anyway, but it doesn't have to be compass terms. What you could do easily is just agree on a directional system that does work indoors. So, for example, it's just an example, and there might be other ways, but you could give walls a colour. In the extreme case, you could actually paint the walls in a particular colour, but you can, just put up a little spot on the wall or something like that. That is not quite as dominant in a room. So, and then you can refer to that. So you can say things like towards the green wall, or next to the blue wall, or on the table at the red wall, or between the trash can and the yellow wall. Things like that, which are completely unambiguous. That don't rely on a viewpoint anymore, because they are clearly oriented towards a particular wall, which provides a direction that is reliable, that doesn't change whenever the user turns their head or walks through the room or whatever. It might require a bit of practice, but I think this really speaks to humans' conceptual and linguistic strengths. These are things that we can say, that we have said, and we can get used to that very easily. It's qualitative, it's schematic, it's can be easily linked up to functions of relationships. And it is totally compatible with the way systems think, because you can easily implement this kind of knowledge about green, blue and red and yellow walls. So shouldn't be a massive problem. And the rest of it, the other remaining spatial terms, should be implementable as far as I know. But technology changes, I don't know all these things, so I'm really curious to hear what you think about that. So open for discussion. Here's my references list. So this talk was inspired from a paper that I wrote a few years ago with a similar title, but I didn't retrace all the steps in that paper, but instead drew on quite a lot of other publications that I have listed here. So thank you very much for listening, and looking forward to the discussion.